Okay, well, how about we don't have a reformation in the car. What if we ship methanol or natural gas to the gas station? You know, because we're already piping natural gas to your houses, right? But there's already natural gas pipelines. It's in your kitchen right now. So, okay, we'll get a hydrogen carrier, not hydrogen, to the gas station. In the gas station, then there you have your reformer, so it's not rolling around with you all the time. You split off your hydrogens at the gas station, and you fill up, and then, yeah, that's where you're really transferring your hydrogen. Unfortunately, yeah, once again, this dog ain't hunting, because if you're already bringing the natural gas to the gas station, why don't you just get rid of that length of hose? What's that, 10 feet of hose? Why don't you just sell them the natural gas? Yeah, okay, so it means you have to have a high temperature fuel cell instead of a low temperature fuel cell, but a solvable problem, very solvable problem.
Rene, I didn't quite follow that. What were you saying about the 10-foot hose?
Okay, so in one of these supposed stations, the station gets natural gas or some other hydrogen carrier shipped in.
Right.
And only at the point of sale does it split off the hydrogens and then sell you the hydrogen. So you don't have a pipeline network, and you don't have a fleet of tanker trucks moving hydrogen. They're moving natural gas or alcohol or whatever. So yeah, the only place that we're trying to move this very weird and exotic fluid is 10 feet of gas station hose. Question?
If you solved all those problems, what do you do with all the carbon left over?
Aha. So here's a plus. They're saying, okay, well, yeah, natural gas at the gas station. Okay, well, one advantage is, what if when you split off the hydrogens, you then save your carbon there, and it doesn't go into the atmosphere. This is one of those ideas that sounds really good in principle, but there are, I believe, 25,000 gas stations in America. So you've pushed the problem one back, that, okay, we're not shipping lightweight gas to 30,000, 25,000 gas stations, but now 30, 25,000 gas stations are now trying to send me back carbon dioxide, a lightweight gas. Yeah, you've aside from just the physical difficulty of it, yeah, it's you don't get the economies of scale that you now have to have thousands and thousands of these little units that are going to be really inefficient. Okay, finally, what about water? Okay, let's say 10, 20 years. Okay, we've perfected splitting up the water molecule. Then the gas station only needs to get water somewhere, which is probably already getting, and then they can sell you the hydrogens. Unfortunately, yeah, logistics don't work out. Looks good on paper, doesn't work out. When you have these thousands and thousands of electrolysis units splitting up the water molecules, they're really inefficient, because each one is only tiny, and you don't have one big plant that can do it really efficiently. And it turns out, once you crunch numbers, how much water is that? You see, because hydrogen is so light, a water molecule is like 85% oxygen. Only 15, 17% is the hydrogen. So you run the numbers, these gas stations are going to be like water mains. I think one analysis said that switching the entire city of Frankfurt to all hydrogen vehicles from electrolysis of water would drain the Rhine for several, the Rhine River would run dry several months out of the year. What a lot of people are talking about is a safety issue, and I think this is a bit much. Especially when you talk to lay audiences. One time I got in a cab with the driver, and he said, "What? They're trying to give us hydrogen. Can you believe these people? Hydrogen ignites with sunlight." Well, let's really look at the safety issues with hydrogen. Ford's hydrogen infrastructure guy, Russell Moy. It's difficult to imagine how hydrogen risks can be managed acceptably by the general public when wide-scale deployment of safety. It's bad. Run away. I'll give him a little slack because he's talking about at the level of Ford. He's talking about Ford having their fleet refueling depot, their test drive depot. We're talking, yeah, millions and millions of liters of hydrogen fueling thousands and thousands of cars. On the road, it doesn't work out like that. See, once again, these problems are awfully circular, that because hydrogen is so light, it turns out your gas tank contains so little energy that it's not that dangerous. Yeah, it is dangerous in that, yeah, the cab driver was right. The energy it takes to light, yeah, hydrogen doesn't immediately burn spontaneously when it hits air. It needs, like wood, it needs a starter to get it going. However, for hydrogen, that ignition energy is so low. What you see quoted in the debate and in the technical documents is don't comb your hair. Static electricity is enough to light hydrogen. Wool, nylon, snapping your fingers, and, like Gabby said, transitioning from shadow to sunlight ignites hydrogen. But, yeah, where the rubber meets the road, some people consider that a safety feature, that because hydrogen lights so easily, you'll get hydrogen fires every so often, but you're not going to get hydrogen explosions because you can never get, yeah, barring like an industrial accident, or like the shuttle holds 1.5 million liters, whatever. Yeah, on the level of a person or a gas station, you're never going to accumulate a big ball of hydrogen that will just light just like that and create an explosion. Especially because once again, because hydrogen is so light, it wants to just disappear in air, gone. The flames from the Hindenburg, the people weren't actually killed by hydrogen flames because the hydrogen went up. People got killed, well, just the fall. It was what 70 feet. And also, when the Hindenburg crashed, it ruptured its diesel fuel tanks. Diesel fuel tanks to run the propellers that actually drive the blimp. And that's what really fueled the fires. Hydrogen was gone by that point. If you really watch the Hindenburg footage, you get this big explosion all at once, and then there's a few fires remaining because the skin is flammable. But yeah, you see, poof, hydrogen goes, crash, and then your diesel fuel is what's burning.